Right, so this is the second lesson in the 5.3 reactivity series, metals and their extraction lessons. So what I'd like you to do is pause the screen and have a go at the do now activities down here. So number 1 and number 2. If you're doing it on your class notebook, then all of this information, obviously the date will have changed, should be in your class notebook. So like the learning objective suggests, we're going to have a look at these words: oxidation, reduction, oxidizing agent and reducing agents, and look at these in terms of reactions. So make sure you get your keywords down and have a go at the core knowledge test. So define the term displacement reaction. More reactive element, or in our case metal, will displace the less reactive metal. Okay, complete the word equations for these. So if you were looking at your reactivity series, so I'll get you one up. So looking at it, we've got calcium and magnesium. So where's calcium? Calcium is there. And magnesium is there. So calcium is slightly more reactive, so calcium will steal the oxide away, so become calcium oxide plus magnesium. Next one then, iron and gold. Straight away you should be looking at thinking gold's the lowest, so there's going to be no reaction there. And then with this one again, silver's really low down, potassium is one of the most reactive metals, so again there'll be no reaction. They are not reactive enough to steal away the non-metal compound. Just put the reactivity series there if anyone needed it. So you should either have this example in your workbook, or you are going to have to note it down, because we're going to be using this example. Be careful of that because it comes out weird on the PowerPoint, so just be careful of where the 2's are. We're going to be using this example quite a lot, so put this equation in your book or make sure you've got it in your class notebook. So there's quite a lot of key definitions, and I'm going to be using this equation to link them to it. So number 1, oxidation in terms of oxygen. So sometimes you have oxidation in terms of electrons as well, but we're looking at oxidation in terms of oxygen. So in terms of oxygen, oxidation is the gain of oxygen by an element. So you always look at your reactants, which are these two here, and compare it to our products. So straight away we should be able to see that aluminium is the one that has gained oxygen. So we would say that aluminium has been oxidized. Okay, so next one then, reduction. Reduction in terms of oxygen. Reduction is the loss of oxygen by an element. Remember, we're comparing our reactants to our products. And if we look at this now, this one has lost its oxygen, so we say that iron oxide has been reduced. Okay, make sure you compare it or comment on the actual compound. Don't just write iron is the whole compound. Iron oxide has been reduced. Oxidizing agent then. An oxidizing agent is an element supplying the oxygen. So what element is giving the oxygen to aluminium? We've already discovered that aluminium is being oxidized. What element is giving the oxygen to aluminium? And in this case, it's iron oxide. That's the one that's supplying the oxygen. It's the compound with the oxygen attached. And then the final definition for the example, reducing agent. In terms of oxygen, a reducing agent is the element removing the oxygen. So which one's taking the oxygen? And in this case, aluminium is the one that is taking the oxygen away, because it is the one that ends up with aluminium in the products. Okay, so I've gone through that quite quickly, but you can always go back and watch the video over and over again. So as a little review, review 1, I'd like you to pause the screen, and I want you to comment on which one is being oxidized, which one's being reduced, which one is the oxidizing agent, and which one is the reducing agent for each of these chemical reactions. Right, let's check our answers then. So which one is being oxidized? Potassium is being oxidized, which makes it the reducing agent. That means that aluminium, iron oxide is being reduced, and that makes it the oxidizing agent. Number 2 then. Calcium oxide is the one being reduced, and that would be the oxidizing agent. Sodium is the one being oxidized, and that would make it the reducing agent. These ones then, they don't have the words, they're just the symbols. So that one's the one being reduced. It's the oxidizing agent, and then that one is the one being oxidized, and it's the reducing agent. Same then as the top one, that's the one being reduced, and it's the oxidizing agent. And then this one is the one being oxidized, and it is the reducing agent. Okay, so we're going to move on now to looking at it in terms of electrons. So to start off, we looked at it in terms of oxygen. Now we're going to look at it in terms of electrons. And a nice easy way to remember this is oil rig. Okay, oxidation is the loss of electrons, reduction is the gain of electrons. Okay, which is going to be a little bit hard because when you're being oxidized, you're gaining an oxygen, but you're losing electrons. When you're being reduced, you're gaining electrons and losing an oxygen. So sometimes it's quite hard for you to get your heads around that. So make sure you copy that down and think about it. So I'm going to do one example with you to kind of show you how you have to display it in the exam. Okay, so elements on their own always have an oxidation state of 0, so they always equal 0. Okay, then we're going to look at the metals within these compounds. Okay, if you looked on your table of ions, which you've got, iron is 3+. Okay, iron has an oxidation state of 3+. Okay, then if it's on its own, it goes to 0, and then aluminium again has an oxidation state of 3+. So you've got aluminium going from 0 to 3+, and you've got iron going from 3+ to 0. Okay, so that's what's happening to their oxidation states. Okay, this information can all be collected from your table of ions, which I'll make sure you've got in your class notebook. Okay, so when you become positive, you've lost electrons. So with that one, it's lost electrons, so we know it's oxidation. This is the confusing thing, because when you become more positive, you lose electrons. Thinking about an atom. An atom, if I was to draw an atom, so I've got positive protons, neutral neutrons, and then I've got my electrons. Normally, you've got the same number of protons and electrons, protons being positive, electrons being negative. However, if I lose electrons, say I lost that electron, I'm going to become more positive because I don't have as many electrons. Okay, we have been through that in class before. This one then is gone from 3+ to 0, so it's gained electrons because it's no longer got a positive charge, so it's gained electrons, and that is reduction. Okay, so I'm going to have a go at another one with you. So I'll do this one with you, and then you can have a go at a couple on your own. So elements on their own, 0. Then if I was to look on my periodic table, sodium is +1, magnesium is +2. Okay, so sodium then is going from +1 to 0, so it's gaining electrons. And then if you think about oil rig, oxidation is loss, reduction is gain, so it's being reduced. Whereas magnesium goes from 0 to 2+, so it's lost electrons because it's now got a positive charge, so that means it's been oxidized. Okay, so have a go at this one now on your own. Pause the screen, and then I'll come back in a minute with the answers. Right, so with this one, that would be 2+, whereas Potassium would be 0 because it's on its own. That one would be 0 there, and then that one would be +1. So with my potassium, I'm going from 0 to +1, and with my calcium, I'm going from +2 to 0. So this one has lost electrons, so has been reduced. This one has gained electrons, so has been oxidized. Final example to have a go at again. Pause the screen, have a go at it, and then I'll put the answers up in a minute. For elements on their own, 0, 0. Look on your table of ions. Copper is 2+, depending on which one you're looking at. Iron is either 3 or 2+. So Fe goes from +3 to 0. So it has gained electrons, no longer positive. Think about oil rig. Oxidation is loss, reduction is gain, so it has been reduced. Copper then is 0, 2 + 2, so it has lost electrons, so it has been oxidized. Okay, so make sure you submit your work, and then if you've got any questions, please email.